Hey, everybody. Thanks for joining. I'm here today with Keith Lazuka, the maintainer of intellij-elm, and we're going to be diving into some pair programming on a new feature and dig into some of the internals of the IntelliJ SDK. Want to say a quick hello, Keith?
Yep. Hi there.
And you want to give us like a little bit of background on intellij-elm and the history and your work on it?
Uh, yeah, sure. I work at Microsoft, and we're kind of an odd duck there. We wrote a service in Kotlin, and Kotlin, basically the IDE to use with it is IntelliJ. And so I was used to using IntelliJ, and we were looking to do the web front end for our system. And eventually I was able to convince them that we were making a huge mistake using JavaScript and Redux, React mess. And we started to use Elm. Luckily, there was an existing Elm plugin for IntelliJ. It didn't have very many features, but it had implemented the basics. It was usable, and I started contributing to it. It was written in Java, but there were some major architectural. Besides being written in Java, which especially Java 8 with the streams and the optional and whatnot. I mean, I just consider that to be a huge mistake in terms of the directions that Java went.
Yeah.
And the direction that Kotlin went in terms of collections and optionals and whatnot. Like, that just was insane to me. So Camille, the original author of the plugin, was no longer, I think he stopped working with Elm or something. He was no longer around. So I just basically rewrote it from scratch in Kotlin. And since then, I've had a lot of help from other people.
Yeah.
Namely AJ, one of my coworkers, and then various people from the Elm community.
Right.
Yeah,
recently. Yeah. So now it's really fun to jump in at this stage because like you and AJ have done so much of the groundwork for just the initial setup and the type inference and optimizing the performance for that. And so it's all hooked in with the IntelliJ SDK. It's not like calling to the Elm compiler to do the type inference and the, compiler error, syntax checking and all that stuff. It's actually like got the whole Elm syntax checking and type inference system built in, which allows you to do lots of cool stuff using the IntelliJ SDK because it understands what's going on.
You're not manipulating things at the like source text, plain text level. You're manipulating a structured document.
Right. Yeah. So, I think it's in a really exciting place, and I think that there are some pretty, pretty useful features that can be implemented without that much effort at this point. So I'm hoping that one of those is what we're going to be diving into today. So let's introduce the problem here. So we are going to be working on maybe we can give a demo of like what this looks like in Kotlin. So,
sure.
Bump up my phone
or from Elm code and just show it red, and
Yeah.
Either way.
Maybe both. Let's see here. Let me bump up these font sizes. Okay, that should be good. So, well, I guess I've worked a lot with this code. So, so if we were to take, I don't know if there's like a greet function and we say, we're going to greet Dylan. And like you can even say, like you can say that this is a string. And so it has enough information to understand that this is going to return a string. And it's a function called greet, and it takes an argument, which is a string.
But the important thing here is that it's a function that doesn't exist. We've written the name of a function that doesn't yet exist.
Yes.
And but we know we want to create it, and we're going to.
Right. And yes. And so we've got an unresolved reference. And so it gives us this hint that would you like me to create a reference? So when you do that, it creates a function here, and this is the deluxe version because it's able from the usage to infer it's got one argument, which is a string, and it returns a string. So now this has gone from a compiler error to a stubbed out function. Like another way you could implement it is you could have it just give you, just return like the simplest hard-coded value that you could create. Hey, Aaron, how's it going? Aaron's asking, how does it know what the types of the arguments are? Keith, you want to take a stab at that one?
Well, in the Kotlin plugin, I mean, here it would be quite simple. You could just statically look at the function call and see that it's a string literal without any fanciness. Yeah. But I suspect that maybe they have some way to do type inference where it's like a type hole where the greet function is like it just knows that it's a function, and then it's going to like infer how to bind it.
Right. Yeah, I noticed that. I think you were saying something recently that AJ, if we take some like Elm code here, like AJ recently added this.
Yes. Well, let's do the comparable example. Here.
Okay. So we say greeting is greet Dylan, and so right now there's no. It's an unresolved reference, but we don't have the option to create it. So what it would do is it would just define something at the top level that just says, so I don't know if it would just return a string or debug.todo. And
yeah, because then that way it doesn't depend on the.
Mm-hmm. Now the ultra deluxe version would be that it would also infer this. I think you were saying something recently, Keith, that like
because
functionality that AJ added where it's like this new functionality that does auto completion of a record.
Yeah, if it knows that it's this should work. Yeah.
So I think that uses a similar like type hole type idea, doesn't it? That the way AJ implemented it, he creates like a valid, he like fixes the syntax somehow to make it able to infer it.
Well, yeah, we fix up the syntax because, like right now it's like this weird thing and you can't do completion from there. But I think we shouldn't worry about this right now.
Yeah.
I think what we should do at this point is let's comment out that everything from 733 to 745.
Mm-hmm.
Oh no, we actually leave greet there. So now go on 730 and do on the greet where we use it and do a Control-Shift-P.
Yeah.
And where it's actually used, not where it's defined, where the call site. So here it can find this. And now if we comment out the implementation, I think what we're going to find is that it's not going to be able to tell you what the type of it is.
Right.
It's not even, it's going to basically give up, even though like it's clearly a function call and it's clearly passing a string.
Right.
Like as is, we don't have the information to do this, and we're not going to dive into this in this stream.
Definitely, yeah.
But we can, generate the stub function with the right arity.
Right.
At least, I think of it, at least in the simple case where all
that would definitely be success for today.
Yeah, right there.
That would definitely be a good place to get to today. Real quick, Aaron was saying, how smart does the Kotlin one get? Or how smart does it get? I guess in Kotlin, all variables in scope are given their type at the point the variable is defined. So how smart does it get? Like, what would be... this is pretty smart that it's like... okay, so how smart does... I guess maybe he's asking about, like, if I were to pass it to a function which takes a string. So if I did... like concated, and I said greeting plus exclamation point. So if I didn't give it this annotation.
Well, if you didn't give it that annotation.
I think maybe that's what Aaron's asking about. He's clarifying, unlike in Elm where sometimes types aren't explicitly given but they're inferred. Right, so if we have an inferred type like this, let's see what it does in Kotlin. Create function greet. Oh, it's not smart enough. That's pretty interesting. I've noticed that in a few places, like in intellij-elm. Kotlin has type inference too, but it's not, that's interesting. It's not inferring from later usage. It's just inferring from the point that it's used here, which is interesting. I've noticed some similar things in intellij-elm. Like you can, you can add a type annotation, and it will annotate it, but it won't annotate. It doesn't care how it's being called elsewhere. It only cares what it knows it depends on, which makes sense. But there could be some interesting things there where, like, you could have IntelliSense features that say, like, hey, this depends on these record fields. So I know it depends, like, so sometimes you'll get something saying, like, that this needs a type A and it returns a string if you don't use the argument A. But maybe it's only passed an int. So you're saying it takes an A, but it doesn't infer from how it's being called elsewhere.
Yeah, it's right. It looks at the type inference is done at each, like, top level declaration level, and it's looking at the body. Right. So it's not looking at the usages.
So I guess Kotlin doesn't do that either. So I would say if not on this stream, but just in general, if we could get parity with the quality of this functionality with what Kotlin does, then I would be very pleased. And it seems like they don't even do that type of functionality. So
yeah.
All right, so where should we get started?
Well, so right now we already have where it detects, hey, you're trying to call a function that doesn't exist. We mark it in red and whatnot. But if you press Option Enter or Alt Enter on it in Elm right now, we don't get a choice to create the function. So where we're going to start is we're going to the terminology for this stuff kind of varies. Sometimes IntelliJ calls it an intention. Sometimes it's called a quick fix. Sometimes it's unclear to me exactly.
Yes, I noticed that too.
Which context that you mean it. A lot of times I call it, in the case where you have something marked with an error and then you provide a fix, I call that
That's
a
a good distinction,
So we already have something that marks that code in red, and that's called the unresolved reference inspection. An inspection is something that you provide as a hook to IntelliJ, and it's going to scan the current file, and you're going to be able to mark it up however you want. You can put red squiggles, you can put orange warnings, you can mark them in gray if they're unused. And so we have this unresolved reference inspection.
Mm-hmm.
And yeah, here's the test for it. So you go back to the implementation. Now, this has to do a lot of stuff because in Elm, you have qualified references, unqualified references.
Mm-hmm.
There's some things that are safe to ignore, and it's kind of a mess. But if we scroll down, I guess let's look at the name of the function in the first place. This main one. Scroll up. So visit element. So this is an override. We see that we're overriding a method provided by IntelliJ, basically. And it's going to call you on every element. So we said that the IntelliJ parses that source text into a structured tree. And the nodes in these trees are these psi elements, PSI elements.
I like psi. It's like psi element. It sounds like telekinesis.
So these are the nodes. And basically the inspection, IntelliJ is going to call you for every node in the tree, each element. And it's also passing you a holder. And the holder is the thing that you, like if you want to mark this thing with a red squiggle, the holder is the thing that you call to say, hey, mark it with a red squiggle and display this error or whatever. So we're going to basically, for each element, we try to find the references. It's not really relevant to this, but it's kind of how the go to declaration functionality works. Like when you want to command click or whatever the Windows equivalent is on a term to go to where it's defined, that uses this reference system.
Or if we do find usages, it's using that.
Yes, find usages uses the reference system.
Which is the awesome thing about using the IntelliJ SDK is you sort of like teach it a few things and then the SDK can do a lot with that.
Yeah. Yep. So inside this big gnarly if, we've concluded that it's an unresolved reference. And you'll see that we're starting to build up some of these quick fixes, like named quick fix and this add fire fix. Like, if we think that, hey, if you just qualify, you already have something imported, like you have imported JSON.D code. And if you just put a JSON.D code in front of this name, you're going to, it'll fix the reference.
Yeah.
So at this point, it could be as simple, after line 72 to just say fixes plus equals and, some whatever name we cook up outside of this if, because, like we're going to, basically what we're going to do just to get started is unconditionally register a fix. Doesn't matter.
Right. So just to give our roadmap a little and our direction for today. So what we're planning to do is just hard code an example fix that's going to always create a top level function greet string, maybe, equals debug dot to do. Like that's pretty much step one. And if we can see that in action, then we're going to iterate from there and actually, not hard code the function name, but actually use the correct one, which shouldn't be too hard. And then we're going to remove the hard coding for the arity, like actually figure out the arity of function. And then we'll probably do some other checks to see preconditions like if it's qualified or not and see if we can run it. But today our goal is to basically, we're not going to do any type inference stuff probably. We're probably not going to do anything with like a qualified reference that would have to be creating a new module potentially or adding something to another module. We're just going to only handle these cases today.
Yeah, and we're going to do the simple always create a top level function. We're going to do that without any tests just to show you how it works. And then we'll switch, because normally all these features I implement in a test driven way. And
but we'll give a little
so we'll switch over to doing a test
so we can show it in action. Yeah, cool.
Yes.
Okay.
Yeah, so let's so let's change that, rename that add qualifier fix to, I don't know, like, let's call this make declaration from usage fix or something like that. Because we already have a make declaration fix, so we're going to call it from usage because this is like from the call site. So yeah, the Kotlin plugin, as we see, oh yes, yeah. So we have a base class called named quick fix, or maybe it comes from IntelliJ. I don't remember.
Cool.
But we should.
Do we need to copy this as a starting point, or create a base?
No, it's too complicated. We don't need that. No. So
we can use this.
The Kotlin plugin provides, even for types, they have the same kind of thing. They can create a class. So let's create a class, and let's extract it to a separate file, and put it in the inspections package. That's fine. It's kind of unclear where to put these things. This is good enough. Now let's make this inherit from named quick fix.
Do you know the shortcut for that by chance?
I don't know if there is a shortcut. I just always just put a colon after it.
Oh, really? Let's
type it out.
Migrate. Okay.
Maybe push members down. Maybe that's subclassing. No, that's not going to work. No, let's just named quick fix. This is provided by our plugin. Okay. I don't know what the other one is. This one's good enough though.
Implement members.
So, apply fix.
Cool. And this is good because we're kind of showing the kind of workflow that it opens up to have this kind of inferred usage functionality.
Yeah, the Kotlin plugin has kind of done it comprehensively, whereas the Elm plugin still has some ways to go. That named quick fix. Where we're
real quick, Aaron's asking what's the correct Elm style. The function will be defined above or below the current function.
I don't know.
I'm gonna say maybe. Well, to start, whatever's easiest. But maybe the ideal thing might be like below. Yeah, below. Yeah, Corey's saying below too. Hey, Corey. So I think below too, because below, I like to think about it as the higher you are in a module, the higher level of abstraction you should be at. So if you're defining a helper, it's probably going to be a lower level of abstraction. So I would put it below. That's my rule of thumb. Cool. So, all right.
So first let's fix that that thing needs a constructor. Do that. Whoa,
nope.
It went wild. We want that. Just manually do it. Change to constructor invocation.
There we are.
And then this needs a string, which is the string that you're going to show to the user in the quick fix menu.
So we need to pass in these parameters like so.
I think the priority, we don't really need to worry about, but we certainly need the fix name.
Yeah.
So this is going to be, let's just call it create. Because we don't know, is it a function? Is it a value? That remains to be seen how we'll deal with that.
Cool.
Okay. So you're overriding a function, and here they're giving you an element, one of the nodes in the syntax tree, and that's the element that like the fix was invoked from.
Yes, right.
Because all these fixes are contextual. But it's just this psi element. It's like, what is it? We don't know.
Actually, we can give people a little sneak peek here. So like if we hover over here, so this is if you're working on IntelliJ SDK stuff, it's really helpful to install this IntelliJ plugin called PSI Viewer. Keith showed me this, and this allows you to inspect the AST as IntelliJ understands it. So a PSI element is just like an AST node, but the PSI part is project structure interface. which just means that like IntelliJ does certain things for like caching the way that it parses it and certain optimizations, and it has certain concrete bits of like the syntax. So it's actually more of a concrete syntax tree than an abstract one. So we're looking at an Elm value. What is this qualified identifier?
Yeah, it basically it parses as either a qualified ID or an unqualified ID. It's a bit of a confusing name.
Yeah, but
the names.
But you can see that it understands
ways.
that it's a function call, which is kind of cool. So so this is when we invoke this here. This is we're going to be given one of these things.
Yeah. I think at the bottom there's the lowercase identifier, and it's unclear it might give you the parent of that, because that's like the leaves are always these like text nodes. So there's two ways to kind of understand what the structure of the document is. One is to explore and run the side viewer on a real Elm file and just see what it looks like. And like, with this function call, maybe if you collapse that Elm value expr, then you'll see, then there's some white space, and then there's an Elm string constant expression. And if you click that, okay, well, you don't have the highlighting enabled, but basically that's the Dylan part.
Cool.
There. So that's one way to explore, is to use the side viewer and whatnot. And the other way is if you switch back.
I found the highlighting. That's cool.
Okay, yeah, cool. The other way is to look at how the parser is defined. And I would recommend the side viewer approach, but you could also look at how the parser is defined. So if you switch back to the IntelliJ-elm project and then do whatever, Command O and search for, or Command Shift O, I always just type .bnf.
Oh, .bnf.
Yeah.
Cool.
Yeah, well, that's it.
Cool.
So if let's see, we were looking at function calls. So do a Command F12. Luckily, you're on a Mac.
F12.
I don't have to translate. I don't have to. Command F12 should bring up the structure view, or maybe just click structure on the left.
Command 7 works.
Command 7.
Right? Oh, I don't have the plugin installed for this.
Oh, yeah, you have to install the GrammarKit plugin. So JetBrains provides this crazy system called GrammarKit, and GrammarKit can take one of these. It defines this BNF grammar, and it turns that into a parser. Generates a parser for you with parse recovery, and it's now if you do Command F12, and we just type in func call expression, because that was kind of the thing we were interested in. So this gives you the definition of how this thing is parsed. And so it's one or more atoms, which is like, the name of a function or whatnot. So you can kind of, like, if, something that might be, I don't know what's relevant here, but anyway, you can look at, to kind of statically see what the possible trees are. You could look at this BNF, but using the side viewer on a real file is much more concrete and kind of easier to understand. Right. But the truth is in that .bnf
if you want to
file.
understand like what states are possible or not and that sort of thing. Yeah, that's cool.
Yeah.
Nice.
Yeah. But I would start from the side viewer.
Very cool. All right.
Okay.
What should we do next?
Okay. So let's go back to that the actual Elm code with so on the greet, so it's an Elm value QID. And that thing has the lowercase identifier as a child, and that's the actual text, like GRET.
Yeah.
So I think we can switch back to the Kotlin code to where we're creating this fix. And so apply fix is being called with the element in the tree that this was invoked on. And I suspect that this is an Elm value QID. And we can verify this. Let's put a breakpoint by clicking in the gutter to the left.
Do I need
leave
the to-dos
yeah,
okay?
Yeah, that's fine.
Okay.
Just put a breakpoint there, and then now do a Control D, or you can click that bug thing up in the toolbar next to
Yeah.
Run IDE.
There's
A lot of ways to
Yep.
launch, but basically we're going to launch it in the debugger.
Right. So
And
Run IDE
because this is
is
a
a
good
really helpful tool. It's actually IntelliJ is launching an instance of IntelliJ with the plugin that we're building. So it's gonna have this like parallel
installed
thing.
Yeah,
I think it's gonna be okay here. Yeah.
Gradle downloads the source code for IntelliJ and builds it.
Might be
and
downloading a new version and running OBS at the same time. It's and it's a heat wave here in California, so it's working hard.
Into the heat wave, we had quite a storm here.
Man.
Flooding.
We didn't have thunder, but it's been hot.
Well, we could start writing this while we wait for that to launch. So I think what we would do here is we can just do a typecast to check to see if this is, let's see, we thought it was an Elm value QID. So yeah, then inside here, I guess generally my style, because we have to deal with, like when you're writing these the IntelliJ plugins, the source code, the tree that you're dealing with could be all messed up. Like there's no guarantees that the program is complete, the user has left it in a bad state. So generally my style in these functions is to just early return if it's not what we're expecting. So like if element not is Elm value QID, then just return with no ceremony, no like logging, no, it's just, okay, so it did launch. It compiled and launched the ID.
It got
Is there a breakpoint still on that line?
Probably. Okay.
Yeah, you got a lot of projects open.
Yeah, I do have a lot of projects open here. Let's see. Let's pick one. Elm Spa example. Elm SP example is good. Okay, so so we want to try to launch this. Do we want to try to recreate that error?
Yeah, any way. It doesn't need to be exactly the same, but sure. Yeah, great. So now we should have that fix suggested. So now we see create. Cool. We didn't have that before. The reason it's got that name, we gave it that name. So now we invoked it, and it looks like the debugger did not break.
Oh, because I didn't execute it. It looks like it got.
Well, then maybe that's
to the to-do
operation not implemented. Huh. Well, you modified the source code after we changed the breakpoint, but it looked like the to-do just hit. Yeah, so let's invoke it. Let's just.
Do I need to restart it?
Yeah.
Or should I just try it again?
No, I think if you just run the fix again.
Oh,
Here we go.
Like hot reloads. I didn't even realize that. That's super cool. Okay. Okay, so now I can do Option F8 and look at stuff, so we can see we've got a value expression.
Yeah, you could play around. You can play around with exploring, but sometimes because of the way that they don't want to have back pointers, and so like the data structure is kind of complicated, and so just looking at like whatever they call them, fields, sometimes isn't there because like the child data maybe is held elsewhere, but yeah, you can do stuff like this.
Well, there's the name of the thing.
So yeah, so the element is actually an Elm value expert. So since I wrote this, I know what this means. It's probably not very useful of a name, but it's just basically a reference to a value or a function that's defined somewhere else. And if we look at what its parent is, let's see what its parent is.
I think it was unhappy about me asking for the parent. Nope, you got it this time.
So the parent is a function call, which is good. That won't be the case when it's just, like in this case, we wrote greet followed by the Dylan string literal. But if we hadn't followed it with the string literal, then it would have just been a Elm value expr. So I think at this point, we need to change that early return to be, if it's not an Elm value expr, then return.
Okay.
Yeah, and then we can get rid of all the else branch and stuff like that. Like I like to make the early return guard stuff as lightweight, as possible, because it's really just ceremony around getting to the meat.
Right. You check problem. The preconditions, and then you don't like it to clutter up the rest of the stuff underneath it. Gotcha.
Yeah.
Cool.
So we want to we're not going to worry about arity, like what the function, whether it's a function or a value and how many args. We just want to generate something.
Yeah.
So you already saw how to get that data, but I think Elm value expr, there's basically there's a psi reference protocol interface that IntelliJ provides. And part of that is
the arity,
giving the name of what that text is. So if you, at this point, we can do element dot reference name, and that will be, in this case, greet.
That's interesting that it says
this is.
It's just is it because it needs to cast it to properly do that? So if I do element as Elm value expression dot reference name. Yeah. Okay.
It's happier.
Cool. Okay.
So I think that's what we should use.
Well, can we hard code something to get something on the screen?
Yeah. Oh, we could hard code.
So we're gonna be using a PSI factory to create a top level function definition, right? That's gonna be where we're going with this. Okay.
It's a roundabout. Should I go into explaining why this is?
Give the short version. Give the short version.
The short version is, you would think, since it's a text editor type thing, that you're just going to have some sort of reference to the file, and you're going to do some sort of append to the string buffer, if you wanted to generate some code. But it's more, or since we've already explained that there's this syntax tree and whatnot, or you would expect, okay, we're going to do tree operations. We're going to be add child, we're going to find where, we're going to add child and whatnot, and we're going to build it up node by node. We actually do not, in general, we do neither of those things. We do a hybrid approach. And so what we're going to do is we're going to construct.
The reason is basically because the IntelliJ SDK wants to guarantee that you derive an AST structure that could be actually parsed, right? And because of that, the recommended practice is that you create text. So you take all of these PSI elements, these syntax tree data structures, we grab the text from them and then build up text for a new syntax tree. And then we say, please parse this into a fresh syntax tree for us. And that's what a PSI factory does, right?
And then we splice it in. I think part of it is in order to get the parse tree right, but it still doesn't protect you. You can still totally trash the document.
Right.
But the other thing that it gives you is it isolates you from changes. If you change your psi tree structure, if you were doing them node by node, the breakage would be tremendous. Whereas this kind of gives you a layer of indirection and a little bit of wiggle room to give you some freedom to change how the parser works down the road.
So can we create something let's just imagine that we said, add top level function. And we're not going to give it a function name or anything right now, but we're just going to say like, here's the element. And I want you to do that. Can we like hard code something that does this in the quickest, dirtiest way we can?
Yeah, except that I don't think it should take an element. Just have it, let's just have it take a string or something, the name of the, the name of the function, and then we can hard code the string. Just change that to name or something. Yeah, and then pass that in. Yeah, you could do add parameter there. Yeah. Okay.
Okay.
Delete the other one.
Cool. So we're gonna need like a PSI factory, which we'll need the project to create, right? So
yeah, and I think it's maybe a little early to be pulling this out into a helper function. I would rather do it right here.
Okay.
Just because then we're passing a bunch of stuff around, and it's a little.
Well,
early.
I was just doing that to like document to give us a thinking tool, but we can do it like this. So PSI factory is going to be, what is it? PSI factory.
Oh, it's Elm factory. Yeah, and then it construct it with the project.
Okay, sweet.
And then we need to have a.
Cool. So we're gonna want to do. Is there like a create top level declaration or function?
No, they're currently not. Most of it's just like expressions and stuff. So
like something like that.
Sure. Yeah, that works for me.
And then we could.
Let's pass in a greet. Yeah. Yeah.
Something like that?
Mm-hmm.
I guess we can.
Yep. Let's not worry about the indentation yet.
Okay.
Let's just get it all in one line just to start.
So we're gonna.
Then you need, after that equals, you're gonna need a space there.
Ah, yes. Cool. Okay. So create a member function, and the way that this stuff works is we create from
those
text.
Are right there.
What's that?
Yeah.
You something like this.
Yeah,
right?
you were looking. Yeah. Yep. Create from text. The idea is we're going to pass in a fragment, and it's going to create a dummy file, parse it, and then pull out the subtree that we're interested in. Yeah.
Well, this is like
we'll want it to return it. It'll be an Elm value decal, I think.
Top level. Value declaration. Cool.
Yeah. And the way that I would know that is by either looking at the side viewer or looking at the BNF.
Mm-hmm.
But that's what our top level, one of our top level syntax nodes are.
What's it unhappy about here? It's not giving me the message because we've got this running. I'll stop that. Can I use nothing? Oh.
Because you're not returning.
Oh.
You either need to tell it the explicit type argument, or you need to return so that it can infer it from the return value, type.
Got it. Right. Okay.
And then we want to change that error message. So this is a pretty roundabout way of doing it, and probably here the implementation we would hide. Like right now, you're constructing the whole function outside of this call, and normally I'm constructing it inside here. But this is fine for now. We can refactor it.
So if this works, then this will be a like function declaration.
Yeah, a value decal, whatever.
Okay.
Could be a zero arity function,
Right.
or so I just call them always a value. Could be a
And
function.
then we want to take like the so we want to find the top level space so we can insert it there, right?
Yeah, we need to splice this into the tree, and we want to find a good place to do it. But personally, I think for right now, we would put it at the end of the file.
Yeah. Okay, so like let's just figure out how to do that in here. So like, or well, I guess here I'll just do this so we have the context of all the values.
Mm-hmm.
So value declaration. So how do I get that right context? I want to find it from the element, right? I want to traverse that somehow.
Yeah, the element is kind of deep down in the syntax tree, so we need to get up high. But every sci element has like effectively a back pointer to the file containing it. So there's a thing called .elm file.
Ah, yes, cool.
And really, it's kind of like a special sci element. It's the root.
Right.
And so now you can do something like add, I think, or append. I don't know. It's one or the other. So add. This adds it at the end.
Oh, well, there you go. Cool. Okay. Should we see what happens?
And yeah, I think at this point we could run
All right. Cool.
Yeah, Gradle kind of takes its good old time. It has to build this sandbox for IntelliJ, and
it seems like a significant job. Yeah.
I prefer to do as much development as I can using tests because the cycle is
Definitely.
a lot faster.
Yeah.
I'm a maintaining standpoint.
It would be insane. Right. But you wanted to give people a sense of the seeing it in action. Yeah. So let's once we see this in action doing this, I think that would be a good time to sort of switch gears and get this under test so we can iterate on it faster. How's that sound?
Absolutely.
Yeah, cool. And for anyone who hasn't seen it in action, testing features in this project is actually quite nice. Okay, so here we go. Let's see what happens. We'll skip past the breakpoint.
So in theory, where are we? We're in this big file.
Oh, wait. Oh, no, that's something that we created.
This is Elm Markdown. Oh, no. Do it again.
Okay, and you know what? Let me delete some stuff here so it's easier to see what's going on.
Is this not the right version of IntelliJ? We're in this Inception.
I'm totally in the wrong version. World. What am I doing? Yes.
Just do a command
there
tab.
We go.
Well, it's nice to have that.
Okay, so greet.
Presumably
it created
this
greet.
one.
It totally worked. Yeah. You know what? Let's just so we can see what's going on. Yeah, let's put this at the bottom, and let's try that again. Let's turn this breakpoint off because that's kind of annoying. Okay, so create. There we go. All right. Success. Great success. Ship it. Yes. This is artisanal code here. I think people will love this as is. Going to be broadly applicable. So cool. So what's a good first step to get some test coverage, to get this under test? create
so normally you would put the cursor on the name of that class, and then you do like a Command-Shift-T to create a test from that local. But I think we should, because like inspections and intentions and
Right.
fixes, this is a pattern that we've followed a bunch of
Right.
times. So there's plenty of examples of these in the project. And it'd probably be faster for us just to look at, like here we were piggybacking on this unresolved reference inspection.
Yes.
And that thing registered a bunch of fixes.
Right.
So we should probably just find the unresolved reference inspection test.
Yeah. Cool.
And there's going to be a lot, there's going to be a lot in
Oh yeah,
here.
and it's even got some. Does it have any fixed, any tests for fixes? Maybe not.
Yeah, just search for fix.
I didn't find fix. Didn't find my fix.
What's in these? Is there anything else unused import? Well, maybe the important thing here is that it's in inspections test base. I think if we just use that base class.
Oh, here's add import fix and add qualifier fix. I think this is what we're looking for. Unresolved reference inspection.
Yeah, so all right, it's
so it's broken out.
To keep the test manageable, we broke it out.
This is actually quite
nice.
So
let's make a copy of this add import fix.
This is actually a very, very nice structure. I think it's pretty intuitive.
How does it know what fix to invoke there? Well, let's copy it and we'll figure it out.
Add, create.
Wait, what's this make declaration fix text? That's like in the wrong place. Oh well. This is from a type annotation. Yeah, that shouldn't be in there. That's package.
What did we call this?
Make declaration from usage fix. Yeah, it's a little weird it being in this import package, but let's not worry about such things just yet.
Yeah, that sounds good.
So this is doing a check. Oh, that's using multiple files. These import ones are complicated because we have to basically set up a test where you have like an IntelliJ project with this file and that file, and so that you can import across files. And really, what we want to achieve here can be done in a single. Check auto import fix. Let's see. I think there's just I think we should just delete all the code out from inside here because it's just going to be too confusing. Yeah. Just if you put the cursor in there and then do an option up arrow a bunch of times. Then hit delete. Yeah, there.
Cool.
There. Now we're good. So let's create a first test. And I write them. Kotlin has this special syntax with backticks where you can have spaces in your function names, which is kind of nice. The only place you use it is here. It's for test names. But it's useful, and it's just basic or whatever. I don't care what we just want to get something working. And then our base class, we have all these helpers that we inherited or copied from IntelliJ Rust, and it can be a bit overwhelming. And but basically, I think we're gonna define this function, and it's just gonna call check fix. I think.
Aaron's saying he stepped back and heard we should delete all the code. Kolya's saying you probably also need to check if the top level function already exists before offering to create it. But I think we wouldn't have an undefined.
Wouldn't have an unresolved reference.
So
in that case.
I think we're good there. Okay, so which test helper are we going to use here?
I think it's just going to be like check fix.
Check fix.
I don't think we should look at these other
Okay.
examples. Those ones are too complicated because it was including multiple files and whatnot. So I think actually I think just check fix by text without highlighting is actually preferable because.
Fix name. Okay, cool. So the fix name is create.
So, yeah, and we'll probably want to factor that out later because it's a bug waiting to happen. So the idea behind these tests is that we're going to have a before, the contents of an Elm file before, and we're going to have a contents of the Elm file after, and we're going to tell it where to put the cursor, what fix to run, and it's going to compare the after with the transfer, what the output of the transformation was. And it's a little fussy because since Elm is white space sensitive, this works a lot better in IntelliJ Rust, where it does the syntax highlighting for the Elm code or for the Rust code in these string literals. But here we have to, flush it up against the left edge or, I don't know. So, yeah, you didn't used to have a module declaration, but I guess that changed in 0.19.1 or something.
Oh, really?
It complains now if you don't have a module declaration.
I'm surprised that it didn't complain about that at some point. Interesting. Okay, so, I guess we can do our example where we're saying my string is well, I don't want to put my name in the source code.
That's fine.
Something like that.
Yeah.
So like the before is this, and then the after.
It's going to be,
I guess we should probably just do a single argument one to start. And should we just call it A?
Yeah, that's fine. Yeah. And let's get it on the same line just for now. And then
cool.
Baby step this so that we don't have to deal with the indentation just yet.
Sounds great.
So the fix, it needs to know these fixes and intentions are context sensitive. So it needs to know where the cursor is. The user's got the cursor. So, although in this case, because I would just put it after the Greek, because otherwise it's going to be too hard to read.
Yeah.
It'll work. It'll work right there.
Perfect.
Yeah. So we have this insane system from the Rust people of using comments to create your own DSL and it loads it into the in-memory text editor, and then it's going to put the cursor there and it's going to delete the comment, and maybe.
Corey is suggesting no argument to start. What do you think of that?
That's fine.
Okay. No arguments there, Corey.
Yeah. Yeah, and
then cool. I'm done with that.
And then let's change the the name of this function to be test, basic value or something. Create basic value.
Create's fine. Okay, cool. Okay. So, cool. Well, should we see if the test crashes and burns? If it runs at all, that would be nice.
It's compiling.
Cue the XKCD.
Because before you were building with Gradle and now you're building with IntelliJ, and I don't know, probably your build artifacts directory is separate.
Oh boy.
Let's look at our code to make sure, while we're waiting for that to compile, let's look at our code to make sure that we at least stand a chance.
My voiceover thing is playing now. Voiceover thing, go away.
I don't hear it.
I do, and it's awful. Go away, voiceover thing. turn off voiceover. Thank
Yeah.
you. Okay, sorry about that. So, sorry, Keith, what were you saying? I
I
could
was
not hear
saying
you.
while we're waiting for that to compile, but let's see. It looks like it's starting to run the
There
test
we go.
now. Okay.
Cool.
It has documentation. How did
that's
that pass?
fascinating. Where's that coming from?
Well, the base class IntelliJ needs you to have HTML for these things
Oh,
so that
did you
they're
add that
post
recently?
settings. No,
Oh,
it should be there, but it should
oh,
fail.
cool. Well, if I just
Um,
run this one, then maybe it won't bug us about that.
yes, it
Shouldn't
will.
have A in generated code. Thank you, Corey. All right. Let's get a proper result.
Mm-hmm.
Okay. So we can see the diff. So for the starting point.
So this is why I was saying check fix without highlighting. So the highlighting, IntelliJ has this
Gotcha.
special markup which corresponds with the red squiggle, that error desker equals whatever. Yeah, I think, does that take 3 parameters? I think this one will not do the highlighting. Because if we put the highlighting in there, it kind of is hard to read, and but it may not work.
It looks like it's creating invalid syntax.
Yeah. Maybe because, can you put a return after in the before on line 14? Put a return after there, or I mean a new line.
Okay.
Because it might be that it's just appending it. No, I think just like that's fine.
Okay. Let's see.
I think that what it did was it tacked it on to the end, in which case it's not syntactically correct.
Oh, I see. Cool. Wow, you're
cool.
You're an IDE whisperer.
That was the problem.
Nice. Okay.
So expected.
So it's actually not adding a new line there. So that's fine. We can get to a passing test hopefully pretty quickly here.
I think there was one other difference.
String.
Yeah, we still had the argument in there.
Wait, where's? Oh,
it's our code that's generating.
Cool.
Yeah.
Okay, so the PSI, no, this guy, it's the wrong hard coding. Okay. And this has like a space after. Do I need to do this?
I would change that. Instead of a triple string quote, I would change it to ordinary string literal. Yeah. And then delete that extra space.
Cool.
It might run the formatter and clean that up anyway. So
okay.
I think it's having trailing white space at the end. I think it cleans it up anyway, but it's still, you don't want that. Just
green. All right. Let's ship it. Let's see what we've got here. Okay, so we're adding that. That's fine. Seems good to me.
It's a little it's a little
lacking in functionality, perhaps. It's not very subtle. That's for sure.
It makes a lot of assumptions.
But the one technique that I really enjoy is Aaron and I used this technique on the stream that we did on intellij-elm recently. I really like finding, getting a test case running and then using the debugger, like hard coding things, and then using the debugger to figure out how to unhard code those things. little by little.
But you got
Which
me.
we can actually,
I mean,
yeah. Well, I mean, uh,
I know it's a
it's
good
nice. I
technique.
like it. I like it. But how would you like to proceed here? Oh, it's time to make the test pass on the Muppet Show tonight. We've got Corey practicing the Muppet Show theme while he's watching the stream. Love it. So what's a good next step for us here?
I guess figuring out the arity would be nice. So we generate the appropriate number of parameters
Okay.
in the declaration.
So should we make a failing test to demonstrate that?
Yeah, I would duplicate that.
Cool. So maybe this can be like exclaim. I kind of like trying to have like somewhat meaningful examples so the test cases are easier to understand what the intention is.
Yeah, I've since tried to make it as plain as possible.
Mm-hmm.
I used to do that.
Yeah, interesting.
And fixtures, this was more of in my Kotlin code, not outside of IntelliJ-elm. I used to like fixtures have like, reasonable names, using Arnold Schwarzenegger as an example for everything. And since then I've switched to whatever the name of the thing is the name of the value. So if it's a thing called name and it's a type string, then the value in the fixture is double quote name, double quote. And that's that.
Yeah, that's a reasonable way to go to.
But
oh, go ahead, Keith.
Yeah. No, I'm torn basically in terms of these kinds of tests.
Corey's pointing out the duplication between the test and the code. So, which I really like this technique too. So I think what he's suggesting is that before we get this test going, that we remove so there's duplication that greet is hard coded. So, so one thing we can do, well, so do you want to try using my debugger technique here?
That's fine.
Okay, so I really like this technique. So we can run it, and our goal is actually I really like doing it this way. So we can like remove this string. We can like actually I think we can this is kind of a cool IDE feature. I think we can do extract variable. If I just do extract variable, nice. So we just did an automated refactoring. So now our job is to remove the hard coding of this word greet.
Yeah, we should have. That would have been a better next step than dealing with the error.
Yeah, that sounds great. So now if we run this with a debugger, we can just figure out how to find this. So we've got the element, and we sort of found this before. It's like QID.
You could do QID.text.
Yeah.
Text is provided by sci-element, or you could more correct here, I think, would be element.reference name. Because we're dealing with an unresolved reference, and the reference name is the identifier that was not found.
I like it. So since we just replaced like a hard-coded greet with something we just showed in the debugger as greet, then hopefully we should still be green. It's still green. So this is just remove hard coding.
Yeah.
Kolya is saying, are you using the IntelliJ type inference errors to attach these? Yes. He's saying he did an LSP language server protocol implementation to this point, but works on every implemented function. Oh, so maybe the language server protocol doesn't have like a hook where there's a problem and you can attach a quick fix based on that, on the type of problem. Is that right, Kolya? I'm curious. Because yeah, what we're doing here, we can go back to this real quick. So,
It's the unresolved reference inspection.
Unresolved. So this is the unresolved reference inspection, and we're only adding it here. We're probably going to have more logic around the cases where we add it eventually, but for now we're just always adding it to an unresolved reference inspection error.
Yeah.
And Kolya is saying I could hook into problems, comma, ... But I only have Elm make, Elm analyze, and Elm test. But inference is coming up. Oh, so you don't know what is in scope or not. So you get the errors of like an unresolved reference from Elm make, not from you figuring out which references can be resolved and which can't, I think is what you're saying, which makes sense. So we actually have access to, in our Kotlin code context here, we have access to what's resolved or not, and we can leverage that.
Yeah, and not through type inference. It's more of just name resolution, like walking up the lexical scope or walking across the imports and stuff like that.
Yeah. Cool. So now we can uncomment this guy and try to figure out the arity. So that's step number 2. So let's see what happens.
On line 33, change that greet to exclaim.
Cool. Let's, that was not what I meant to do. I meant to run this test. Okay. Cool. So let's see what happens. So it gets exclaim, and it's doesn't know the arity. So let's see, where is our make declaration? So how do you think we'd go about figuring out the arity?
Well, let's look at this thing in SciViewer. So switch to, you had another project where you had Elm Markdown or something.
That's right.
And just find a simple case where you, there we go. And yeah, here, just based on how it's parsed, we see if we go up, we have an Elm value expert, which I think is the thing that we're dealing with. And its direct parent is this Elm function call expert. And if we kind of flatten all those children there, you'll see that there's like one node and then there's white space and there's another node. And these names here in SciViewer, like Elm function call expert, Elm value expert, those correspond to classes. So the next thing I would do is I'd switch over to the Kotlin and I would try to open a class called Elm function call expert.
And you have arguments which we can count.
Yeah. So this is like really the crux of our domain model are these Sci-element subclasses. And we've tried to provide properties and functions here that are useful for implementing features on top of the syntax tree.
And you know certain things about the AST, like you know that each of these is going to be an atom tag, which you actually showed us here. That's this. Yeah. And the first one is like the name of the function call. And so you're dropping that. Yeah. So you're using your knowledge of the AST and encapsulating that in this class.
Yeah, this hides it, you know, and the target is that first one, which it should always be probably, you know, some kind of, it could be a lambda or it can be the most common is it's an Elm value expert. But like here, it syntactically allows it to be like a list literal, even though that would be wrong. Like we don't
Right.
catch. You have to. You can't catch everything
Yeah.
in the parser. Or there's other ways to report those errors.
Mm-hmm.
So anyway, we have the arguments as a
Mm-hmm.
sequence. So we could count those.
Right. So, okay. So using some
So
TDD here, like, here's a thought. What if we said, what if we just made this test pass by saying if, well, I guess we can just say if element dot, let's see. Let's just get the test passing by saying if S is greet, then we're going to do this. And otherwise, let's see. Otherwise, we're going to do this. And I think that will just make the make our whole test suite green. And then we can do it a more subtle, nuanced way. But so that makes the test happy. Let's make sure
it was just
it's
that
going to
one.
be unhappy about the missing HTML documentation thing, but we don't care about that right now.
No, that one passed the first time somehow.
Oh, well, that's fine with me for now. At least they're all green. Corey's saying, love it, makes the test pass by adding code, then refactor by eliminating duplication. Exactly, yeah. Yeah, I'm a big fan of that, Corey. Especially with, like, coupled with the debugger, it feels so nice. So now, I just love this. I love, so, like, okay, check this out. Let's say, let's call this like has arity 0, for example, right? Now we can like change this condition. So now we get to change the has arity 0 condition, and we can make the tests continue to pass. Make sure that's still green. And then we can add a breakpoint here. So now let's run this guy with a debugger. And then we'll find a better way to say whether this is true. So, so the element is an Elm value expression. So are we going to be like looking in the ancestor tree to find a function call expression, or how would you figure out the arity? Yeah.
Yeah, I mean, in this case, I would probably, play around with the side viewer or look at the BNF, but the parent is either going to be a function call expert or it's not. If it's not, then it's a case where it's just a usage with no arguments after it. So,
right. Okay.
If all you care about is whether it has arity 0, then it's as simple as checking to see if the parent is not a function call expression.
Right. So we could do something like
and you could default that to 0 if it's not, if it use this operator.
The what operator?
It's Elvis.
Oh, is
operator,
it this?
Mark colon.
I always find that one really weird, but so cool. So like presumably this is the arity, and we can try that out by just saying arity equals 0. So now And I mean, since we've got the debugger open, I guess we may as well just make sure that this thing works, which it does. So now we can run our whole test suite again. Sure. Yes. Nice. So, great. Has arity 0. I think that's a reasonable commit.
Mm-hmm.
So handle arity of 1. Interesting. Hey, J rare GRLS. Is this Odmund? I can't remember if that was your handle, Odmund. Is that you? Either way, thanks for joining. Have a good night. So cool. What's our next step here? Odmund, cool. Yeah, thanks for joining, Odmund. Take care. All right, Keith, what is a good next step for us here?
I think, going beyond arity of 1 would be good.
Like arity of 2?
Yeah.
Sounds good to me.
But preferably without just continuing to do if tricks.
Well, I think
Otherwise,
I think this test is gonna force us to get past that, which is good. So okay, so let's go back to our greet hello world, and we'll say that
let's just use some lowercase letters.
Yeah. Awesome. Okay, and so let's run it and see what happens.
Mm-hmm.
So I think we can.
I don't know.
I've never seen that. I'm just gonna.
Maybe because you have the debugger running. You have the debugger active right now.
Oh, I've got like a double debugger.
And
there we go.
Well, and it might be that because debugger was running with Gradle, and then IntelliJ is running the tests, and then maybe if they share the artifacts directory, then then it's like, oh, the class file changed.
Got it.
It might be something like that.
So this is the failure we wanted. Yeah, that's great. So so now we're gonna have to get a little more clever. So I mean, I think basically what we're gonna do is if we had a function that said like arglist from arity. We can change the names if we think of a better one, but arglist from arity, and it's just gonna, so let's just do one more cycle of the ifs here, and say if arity is 0, then it's going to be this. And if the arity is 1, then it's going to be this. And otherwise, it's going to be this. And I think that would be enough to get us to a passing test.
Probably need the spaces to be kind of normalized, because in the 0 arity case, you're not going to have a found
do it like
space.
That. Yeah. Or this is simpler. Let's do it like that.
Okay.
I guess. Yeah. So
change that if just to show people, change that if to a when.
Cool.
And then single line those. If you all you have to do, or do a Control Shift J. If you do join lines, it automatically removes the curly brackets.
I think I have.
Either way. You can do.
There we
yours
go.
is Control Shift J.
Cool. Oh, that's neat. I haven't used
In
that.
general, with Kotlin, when reads nice, and
that's awesome.
Especially if you're going to have multiple branches.
That's very cool. So then this is going to be like we should be able to call. Well, we've got the arg list.
We should be able to get rid of this duplicated branch. We just pull that up.
So this should be like arg list. Like, let's see if our test suite passes with this.
We're going to have too many spaces.
Right. Yeah, we'll see. No, it's green. Okay, so now we might be able to just do this. And if that's green,
yeah, it's going to fail this arity 0, 1 because of the extra space.
Extra space. Okay. So.
Well, let's look at it just to see.
We could then let's do this.
Yeah.
Okay.
You hear the kids yelling. They're playing Minecraft. They're taking advantage of the on the stream. They're just going.
That's great.
Playing video games as much as they can.
Well, let's. I think we're pretty close to meeting our goal. So let's try to remove the hard coding for this arity thing. And then I think that's pretty good for today. And so let's see. Okay, so how should we remove the hard coding here? Any ideas?
Let's see. We've done name stuff in numerous places.
Yeah.
But I think a lot of times it was more like
checking what's in scope to get a fresh thing.
And adding suffixes and stuff. I guess I don't even know how Kotlin's if you just want to do some kind of ASCII, like in C, we just start with the A character and add on some integer index and whatnot. I don't know what the trick would be.
Corey is suggesting we could do arg1, arg2, arg3, arg4. That definitely sounds easier. I like the sound of that. What do you think of that?
Yeah.
Okay,
sure.
So let's we can change our test. So let's find our A's and B's and change that to arg1 and arg1, arg2. We should have failures. Then we can change this to arg1, arg2.
Yeah, I think probably for Elm code, it'd probably be better to just use these lowercase things. But in the interest of getting past this point, that sounds good to me.
Yeah, that sounds good. arg1. Wait a minute.
That's fine. No, it's correct.
Oh, we're just not doing the right thing.
The code is not updated.
Cool.
Yeah.
arg1, arg2. Okay. All right, so
I think what we can do is get rid of that one branch.
Mm-hmm.
Delete that one entirely. And then on the else, we can construct a range. Like Kotlin has some syntax for if you do 1 ... arity,
Mm-hmm.
Uh,
Is that inclusive or
and then I think
exclusive?
it's inclusive.
Cool.
It's inclusive, which is what we
Mm-hmm.
want. And then I think here we have to put this in parens
Right.
because I think the precedence is low. And then do like you could do a map and then just suffix it onto arg $it.
Target.
And then you could do join to string with a space separator. So join to string, it takes a separator, but it can also take a transform. And here this is inefficient and it's suggesting the fix because you're doing a map first, you're creating this temporary list, and then you're going to join it. And actually, join to string can do it in one pass. But so we have a space issue.
I think it's just like this.
Yeah.
I think that should be green.
No, that's going to give us too many spaces. It's the final one. It's going to be the final one that needs an extra space. See, that gives us too many spaces in the intermediate ones. So we just need to suffix, turn it back the way it was.
Oh, of course.
That whole expression at the end, the very end of it. Actually, I think join to string probably takes a suffix overload. Postfix, yeah. You could just do space.
Sweet. Yep, I think that'll be green.
I mean, here obviously the efficiency doesn't matter, but
yeah, it's definitely not going to become a bottleneck anywhere. That's for sure, unless somebody's like really quickly creating functions from inferred usage. Cool. So we're green. So that's great. I think that's a good commit. And it there are certainly some cases to handle, but almost usable. So handle arity without hard coding. Okay, so let's run what we've got right now. Take a quick look, and let's write a little to-do list of what we might want to see here. So, okay.
The one thing for sure is that we're not guarding. There's a lot of unresolved references, like a type reference that's wrong. This is going to be suggested for a type reference. And, we only want it to be suggested for value, function, basically lowercase type things.
Okay, and then handle qualified, references.
Yeah.
Or defer to later and don't suggest fix. Corey is saying, I'm curious about Kotlin range creation. Would be cool if 1.0.map yields empty list. Ooh.
I think it does, but I was thinking about that, and I don't know. It seems I'd rather be explicit about it.
Get rid of case statement. Yeah. No, that makes sense. You can. I mean, we've got the test, so that at least we've got that giving us confidence. But, okay. So, okay, let's see this in action.
Yeah, delete that.
Okay, here we go. Here's the fun part. Create. Hey, that's amazing.
Rename the function. Change greet to be exclaim or whatever. Make sure we have this.
That's pretty cool. That's not bad for a stream.
So another important to-do thing is I don't know what they call it, but basically to generate the code and then put the focus and the selection on the generated arguments so that then you can easily tab through them and hit. It's called the what is it called? Make declaration. Make declaration fix does it. It's called a template. Use this template manager, and it doesn't look that hard to do.
Awesome.
But yeah, just see make declaration fix.
Hey, we can turn these guys into boom. Oh, and Aaron's saying then Elm format. Yeah, or I mean, ideally, it would be amazing to use Elm format. Aaron and I discussed this a little bit. When I tried running it between calling npm and running Elm format on the whole file, there was a noticeable lag. But Aaron's been talking about using creating an option to Elm format where you can just call it with a single expression, which would be really cool. And Aaron was also talking about the possibility of like calling Elm format without the npm bin wrapper, which would make it more performant, which would also be cool.
Or could we have a daemon that like listens to
cool.
Some kind of message, have a process running, and have a Elm format daemon and
that'd be huge.
Pass expression to it, without restarting the process.
Yeah, that would be fantastic. I would love that. It would definitely have made my life a lot easier with the pipeline refactoring. That was not fun.
I warned you. I told you.
It was so fun.
I said introduce variable. I think nearly put me over the edge. I don't think I.
But this one was pretty fun. This was not too bad. Famous last words. Knock on wood. Okay, so let's see. What else is there to handle here?
Indent the body. The body expression should be like new line indented. I think the qualified reference thing, I think we should just punt on it. Like in terms of how I write Elm code, I would say it's more of a helper function that I'm constructing. And I mean, I could see why it would want to be done later, but it seems like almost always I would be doing it for the current file.
Really? I would find it very useful to be able to do it for qualified imports, but I really like the idea of shipping it in this form and doing it as a follow-up thing. Oh, Aaron is saying I'd be up for a daemon or daemon, however people want to pronounce that. It's controversial, I know. Though I wonder what is a good pattern for that. The IDE would manage the daemon, or maybe just the CLI would have an option to stay in memory for some amount of time automatically. Yeah, it's a very interesting question. I think that'll take
something definitely worth talking with Kolya about.
That's a great idea. Yeah, maybe we can get a little editor powwow going. That'd be cool. Okay, so add new line. Add the option to give better names.
Oh, and
yeah,
the location where it's inserted. Should be below the current function.
Call site function body, not at bottom. Yes, and then also like the more deluxe thing would be like having type annotations. But are you thinking that it would make more sense to like create the function and then you can use a create annotation?
Yeah, I mean, if you went and implemented the function, then you can use the add type annotation intention that already exists to generate it. Because otherwise, I don't know what it would take to get to be able to do the type inference with like an unresolved function where it's like a type hole and like it can kind of tell you what it needs to be to type check.
Do you think it might be viable to do it as a like a workflow where you call create? So you call create, and then so you're talking about this. which, well, so now that's
Yeah,
interesting so here's the challenge is it's not, I guess you can't really know because until you know what you do with the body, you don't know unless it's like a custom
yeah.
type. If it's a custom type, you know.
It's a custom type.
If it's like this, I don't I don't know why you would exclaim the user and their credentials, but with that aside,
Yeah, leak those secrets.
if you add a type annotation, it should be
You're saying whether you should start from the implementation or whether you should start from the type
yeah, it
annotation,
does seem like it would be
like
a
in terms of what to
useful
generate.
feature. I would certainly appreciate it as a user if it could be like, oh, this is definitely type user. And if it would just be like, yeah, this is type user
Well,
and this is
yeah, and there's some
credentials.
other things like list literals. Well, maybe not list literal because you can only go so deep.
Mm-hmm.
But I mean, there are some static, naive things that you could
Yeah.
do, like a best effort, like an integer,
Right.
literal.
Right.
You could do that. Um, and
Yeah. Although integer is another interesting one because
but
it could technically be a number, not an integer, and yeah. But I think it would be worthwhile to throw in a few heuristics where it's like, okay, I can help you out here for sure. Maybe it's not going to perfectly get the annotation, but it can do what it can do confidently. That would be cool.
yeah, I was thinking about generating the body, and instead of doing like arg1, arg2, or whatever, it would just lowercase the parameter. Like, if you get rid of 418 and 419,
Yeah.
you delete those, comment out those lines,
Mm-hmm.
and now you put the cursor on that line and do an option
Mm-hmm.
enter. See, I already have this. This is the make declaration fix, and this is using the template thing to kind of feed you through here.
Yeah.
Now, see how I default those
Yeah.
arguments based on the name and
Exactly.
type,
Right. Exactly. Yeah.
and I have a few heuristics to, like it might be like record or whatever. But in that case, it's kind of, I'm dealing with a simpler input because here it's the type annotation. And what you're talking about is the arguments at the call site. And it could be like a parenthesized expression.
Mm-hmm.
It could be,
Right.
but I agree, it could be, you still could do some
Yeah, I
stuff.
mean, just some heuristics where it's like sometimes it'll do better than others, but like at least if there's something where it's like, oh, here, this is a value, and I know the type because it's annotated or it's like a literal that I can easily infer or whatever, then in those cases, at least
Yeah.
just use that information. That would be cool. And then, so
Yeah.
use argument template names based on types like other, like create from declaration. So those are two things to consider. But so, okay, cool. I think, so I think this is a pretty solid list here. So things we could handle for this main PR. Don't suggest for unresolved type reference, for unresolved type
Yeah, that's the
references. Mm-hmm.
requirement.
Handle qualified references, or so we're saying just for now,
I would
don't.
say don't ignore qualified references or don't suggest fix for qualified refs.
Make sure cursor focus goes through argument names, the template thing, add new line, get proper formatting, insert it at the right place, not at the bottom always, and then some things we could consider now or maybe defer is some heuristics around inferring types and argument names. So I feel pretty good about that sort of roadmap and where we got for today. That was a lot of fun. So let's let's wrap up. Is there, do you have any parting thoughts, Keith? Anything you want to highlight for, things that somebody who wants to, contribute to intellij-elm might want to know, or, any words of wisdom?
Well, you just wrote up a contributing.md file, which is in our repo,
Yes.
and I just added to it. So there's some new tips in
That's
there,
awesome.
some links and things that you might want to peruse.
Very cool.
So, that's something to look at. I would say in general, like you're not going to need to modify the parser or anything like that. Like a lot of the core infrastructure is built and you can build on top.
Mm-hmm.
Read-only features are particularly easy to implement. So like if you wanted to write an inspection to see like if a module is unused or something, like that would be pretty easy. It's when we're generating code that there's just a lot,
Formatting.
it just gets complicated
Yeah.
because of formatting, because of the whole, like, it has to be a proper syntax
Mm-hmm.
tree, and you have to be on the right thread, and but doing read-only stuff, that's fairly
Right.
straightforward. And there's a few places, where like I punted on unused, like detecting unused type variants and
Right.
stuff like that.
I think there could be some low-hanging fruit too for example, for like little tricks for conditionals and Boolean logic. So if I don't know, if you say true and something, then it's not too complicated to just say you can always reduce that to removing the true and. You can get to more complicated cases, but there are a few cases like that might be able to like put you on a path where you don't have to deal with the complexities of all the formatting and all those sorts of tricky bits.
Yeah.
So, so Aaron Vonderhaar and I created like a little Notion board that we're using to track some ideas, because Aaron's working on a tool called Elm Refactor that does some automated refactoring, and Kolya is working on some refactoring support in the Elm language server protocol. So we've got these sort of 3 different projects working on automated refactoring. So we're trying to sort of share ideas on some recipes for refactoring. So we've also got this Notion database here that describes a few ideas that we have, some of which are pretty low-hanging fruit. So lots of fun stuff to explore. But and of course I completely forgot that people can't see my screen. Here's the Notion database. I'll share a link to that when I post the YouTube video. But I think that's probably plenty for people to take in one sitting. So let's leave it at that. And this was a lot of fun. Thanks so much for joining, Keith, and looking forward to collaborating more.
Yeah, I'm appreciative of all the contributions that have been made over the last couple of years, and I'm available on Slack if you have questions or create a GitHub
Awesome.
issue.
Thank you so much, Keith. Yeah, it's really Keith has been super thoughtful about his comments and testing that he's done when people make pull requests. I've had a really great experience, so I really appreciate your sort of leadership of the project, Keith, and all the great work you've done. And this was a lot of fun. So take care.
So long.
Bye, Keith, and bye everybody else. We'll talk to you later.
All right. Bye.